Welcome everyone. Once again, I want to welcome you all to this presentation on Apache Payment and our real-time streaming lakehouse with Apache Flink. Okay. Here's what we're going to be talking about today. So we'll do a quick overview of the current streaming landscape and where does Apache Payment fit into the current landscape, and an overview of what Apache Payment is, how is it useful, some features of Apache Payment compared to some of the other data lake houses. Although we'll not be doing a deep dive in terms of the comparisons, just to give you a picture of why exactly Apache Payment exists and its integration with the Flink. So that's going to be the focus of the talk today. And I'll be focusing around primarily the CDC use case, that is getting change data from databases into Flink and storing them with Apache Payment. I don't think I've added a slide for my introduction, but I'm Avinash. I'm one of the co-organizers of the meetup. I work as a platform engineer at Platformatory, where I consult around the data infrastructure, primarily Apache Kafka, Apache Flink, and Apache Druid, or even Apache Pinot. So all of these projects are something that I work on every day with an infrastructure lens. Okay, so here's what the current streaming landscape would look like if you were to visualize it in terms of an architecture diagram. You would get all of your data into a streaming pipeline such as Apache Kafka using a connector framework and perform any sort of processing on it using a stream processing engine like Flink or even Kafka Streams for that matter. But Flink is more prevalent in terms of stream processing because of its integration with, because of its capability to do both batch processing and stream processing. And then you would want to sync it to somewhere for querying either real time or such as in real-time OLAP, such as Apache Druid that we saw in the earlier talk, or you want to maybe do historical querying as well at a later point of time. All of those are data that you need. Once you process them in a streaming pipeline, you would sync them to any data sync. And then along the way, you would also have some um, data lineage to look at how your data is flowing through the various stream processors, and also some observability around it. But with that in mind, I want to talk about where does what are we heading towards. So there's a lot of choices out there for the stream processors, or even for the data lake houses for that matter. There's Apache Flink for stream processing. There's also similar tools like Kafka Streams or even KSQL, or there's a whole bunch of stream processors that are out there. And also even in terms of the data sinks, that is the lake house where we want to query data in real time. There's a lot of options out there, such as Apache Iceberg or Apache Hudi. If you've been to one of our previous meetups, we've had talks around Apache Hudi as well. So what I want to get to is there's a lot of options that are emerging out there. So how do you pick and choose between these various options for the particular use case that you might be trying to solve? One common pattern is all of these data lake houses are built on top of S3 because it is cheap storage, and it is also getting very fast with the recent announcement at the AWS Summit, where they have a global endpoint for quicker S3. So S3 is getting much faster, which means S3 is going to be the default storage for such data lake houses. And there's a lot of query engines that are being built out of as well on top of these, such as Presto, Trino, or even Flink for that matter can be used as a query engine on top of data lake houses. So I want to particularly talk about the stream house pattern, that is streaming with the data lake house. And particularly talk about Apache Flink and Apache Payment today. But here's what you would typically want to solve for. That is, you have a database which is generating change data of all of the data that is being generated. You capture that using any of the CDC mechanisms, and you want to process that, because the data in the database is in its raw format. It's not really helpful for any analytical query. You would want to process that using any stream processor. This is where Flink comes in. And once the data is processed, you want to be able to query it in real time. That is, you want to be able to query it as it is being streamed. That is where streaming data lakehouse comes in. And the ones that I spoke about earlier, such as Apache Paimon or Apache uh, Hoodie or Apache Iceberg come in. So this in this particular diagram, we can take a look at where the data is being captured. The CDC data is being captured from the databases, and it is being processed by Apache Flink, either in a streaming fashion or even in the batch fashion, across multiple business facets, ODS or DWD or even DWS, and then finally being synced to a data serving system, which is our data lakehouse. And all of these can be queried at any given point using any of the query engines such as Presto, Trino, or even Flink or Spark SQL. And this is where Apache Payment comes in. That is, it is a data lakehouse that allows you to query data at any point of time as and when it is being processed in Flink. That is, there's a concept called dynamic tables in Flink, where the data is persisted in very similar to a materialized view in a relational database at each and every point of our streaming pipeline. For example, if made some processing changes, and the immediate results of those processors are also persisted in a dynamic table. The idea with Apache Payment is to be able to query that intermediate results as well, so that even the intermediate results are useful for the longer run. So quickly to go over some of the features of Apache Payment. So since it is meant to be a data lakehouse that is native to Apache Flink, it supports both streaming and batch processing. And it has the typical data lakehouse capabilities, that is low cost through the storage such as S3, and also highly reliable because it is a distributed system at the end of the day. And we'll cover some of the internal details as to how exactly this is achieved. And the merging in Apache Payment is slightly different to the other data lake houses. For example, other data lake houses might merge on write, that is, but Apache Hoodie is merge on read. So that way, you don't really merge preemptively. Apache Payment, Apache Payment uses a data structure called LSM trees, log structured merge trees, which allow you to not perform compaction very eagerly. That is, the compaction is only performed when there is a need for it. As and when the data arrives, the compaction is not performed. This way, it is a lot more performant compared to the likes of other similar data lakhouses. And it also comes with a changelog producer, which is what I'm going to be showcasing in the demo. But the idea is what I spoke about earlier, that is getting the change data from data sources into Flink and then processing them. So there's a native way of getting change data from the databases with Apache Payment. Unlike the need for external CDC systems, this can be done natively and all through a Flink job at the end of the day. And even with the table types that are supported in the data lakehouse, there's multiple ones. The default one being the primary key table, where it's the usual primary key where you can do insert, updates, deletes. Or if you have a same record with if you have a record with the same primary key, the record gets updated. That's the default behavior. But it also supports something called an append only table, which allows it to be used as a message queue as well. That is, all the records that are coming into the table are only appended. There's no concept of updating or deleting. And it just allows you to use Apache Payment as a messaging queue as well, if necessary. And this also solves a lot of use cases around the logging, where you just want to get append data to logging structure. And it also supports schema evaluation. So as and when you make changes, schema changes to your source databases, that is add columns or rename columns or alter columns, alter the data types, all of those are automatically picked up by the changelog, the CDC mechanism that I spoke about earlier. So quickly to talk about the internals a little. So like I spoke about it earlier, where the Apache Payment uses a structure called LSM trees, which is a bunch of SST files that are only compacted on read. That is, they're not preemptively compacted. Maybe we can have a larger discussion around it at a later point of time. But this allows for better performance and effectively allowing us to filter or predicate the push down. That is, in the LSM tree when the files are only merged on read. And it also supports various formats. You can use the ORC format or the Parquet format. You can either use a row-based format or a row columnar format. And there are multiple query engines that uh, you can use to query the data once it is written to Apache Payment. So there's Apache Flink, Apache Spark SQL, or Apache Hive, Trino, Presto. All of these are engines that you can use to query the data once it is written to Apache Payment. So it's not just Flink that you would use to query data. You can use other systems that you are maybe already using to query data. But the advantage of using Apache Payment is it is natively comes with Apache Flink. That is, whatever processing that you're doing with Apache Flink, if you're already using Apache Flink as a stream processor or even a batch processor, all of those data can be synced to Apache Payment, allowing it to be queried using any of the engines. There's also self-managed metadata store that you can use. For example, you can use a Hive meta store for storing all of the metadata. And there's also this important concept of snapshots, which is also available in other data lake houses like Apache Iceberg, which allows you to snapshot data at various points of time, as and when they're being written, maybe as and when you have a schema change or a particular, whenever the data is being flushed, a snapshot is created, which allows you to time travel. That is, at a you want to maybe query the data that was written a day ago, you can still do that with snapshots. Yeah, there's a concept called tags in Apache Payment, where as and when the snapshot is being created, there's a tag associated with it. So you can query the data using the tag historically. You can query the data historically using a tag, allowing it for offline usage as well, not just streaming queries. And I don't think I have a slide around it, but to dive a little more into the internals, there's a concept called all data that is written into Apache Payment is partitioned into buckets. And the buckets is the underlying structure that stores all of the data. But a layer above that is um, tables, which is what we query with Apache Payment or any of the which is what we query with Apache Flink or any of the querying engines. The each tables can also be partitioned. So the partitioned columns can also be are also further broken down into buckets. Right? Probably a diagram would have helped here. But with that, uh, I want to jump into a demo and show you how you can get data from MySQL database using Flink CDC and query them with Payman. Yeah. Yes. Flink CDC is something that comes with Flink out of the box. It's a capability that is built into the Flink, uh, and that is also being extended into a payment. So there's no external tool that you would need to do CDC, unlike with maybe other systems. For example, if you want to do CDC with Kafka, you would want a DBZM connector, or depending on the database, you would want some sort of CDC connector. But with Flink, there are out-of-the-box CDC connectors for most popular databases like MySQL, Postgres, or MongoDB. All of those are supported out of the box. So I have a rather simple setup here. I'll create a GitHub repository out of this and share it at the end of the talk when I share the rest of the slides. But a quick overview of what the setup comprises of. There's the Flink job manager, which is what accepts the Flink jobs, and there's a task manager that actually performs the Flink jobs. That actually runs the tasks in a Flink cluster. And I've also added Presto for querying the data from Apache Payment. And there's a MySQL container that acts as our data source. This is where we'll be inserting data and trying to get those data into Apache Payment and then querying it with the various query engines. There's an Hive metastore which is not really used, but could be used with Presto. So it's just a metastore that can also be used. So with that, I think there's no other configuration that I want to talk about. So I've changed the checkpointing interval to 20 seconds so that the snapshots are created eagerly so that I can actually show the snapshots being created. By default, I believe it's 1 minute or so, so that in the interest of the demo, I've changed that. And I've also got an init script that initializes the database for me, creates a table and inserts a few records into it. And the database is also enabled with CDC. So that's all configured. And I'm using S3 as the underlying, as the file system for the data lake. So I've created an S3 bucket and I'm using it. So now that the setup is up, okay, all containers are running. Now let's start by creating a Flink job for the CDC. So I'll be using the Flink payment action jar and creating a MySQL sync database job for Flink, where it will sync the entire database. So I've got a database called DemoDB in my MySQL container, which will be synced entirely. So any table that is inside the MySQL database called DemoDB will be synced. I'm storing the data in Parquet format in the payment table, that is the Flink table, and I'm setting the number of buckets to 2 and setting the sync parallelism to 2 so that there are 2 tasks that are running parallelly for the syncing. Let's submit this job. Uh, this might take a minute or two because of my network connectivity. The file system is in S3. You should have probably used a local system. But I wanted to demonstrate the fact that S3 is a first-class citizen here for storing the data, because that's what you would use in a real-world situation as well. You would want to use S3 as the file system rather than using local system, because S3 is cheap and also reliable. Let's take a look at the Flink UI for the job that is submitted, and we'll quickly start querying the data and maybe demonstrate a schema evaluation as well. Okay, the job that I just created is here, the S3 sync, MySQL payment database sync. There's 3 records that are received. I should probably show the source database to show that there are 3 records. There's a table called inventory that I'm using to source the changes from the MySQL. So there's 3 records in the table inventory, all of which are being picked up by the CDC connector into Flink. And now we should be able to look at the S3 bucket as well. Just query emptied the bucket at the before the beginning of this talk. bad time for the session expiration. Okay, in the meanwhile, I think we can just look at the other querying engines, and then we'll get back to looking at the S3 format. So I'll start a Flink SQL client here, and we should be able to query the data from Flink as well. I will create a catalog here in Flink for querying the S3 bucket that I've provided for the previous job that I created for CDC. Okay, S3 is loaded. We have a directory called payment, which is our root directory. And the name of the table that I provided for payment was S3 demo. So there's a database that is created there. And the table that was in MySQL is inventory. Let's take a look at the schema file that is generated. So the structure is somewhat similar to Iceberg, if you're familiar with it, where there's a schema directory which contains the schema of the tables, and the snapshot directory contains the snapshots that are created with a reference to the earliest and the latest snapshots. And the manifest directory contains a list of manifests and the manifest list file as well. It's somewhat similar to how Iceberg structures its data as well. Let's take a look at the schema file. This is just to demonstrate that the current schema, and we'll look at the schema evaluation as well. So right now we have 4 columns here: the ID, name, price, and stock, and all of these are being captured by the Flink CDC and returned to payment, and with the table format payment, which is generating this schema. So we also have the buckets that are created. So there's 2 buckets that we specified. Buckets is where the actual data is stored. So there should be a bunch of Parquet files here. There's a few Parquet files for the changelog that is captured. And with that, should have our. We've created the catalog for the S3 in Flink. We'll use this catalog and query the data. And the database name is also called S3 demo. I've named the catalog with the same name. So I'll use the database. And now I should be able to look at the inventory table here. If I do show tables, there's the inventory table. Let me switch the execution mode to batch so that the query is much more performant. And now I'll select all the rows from the inventory table from Flink. So this goes to show that once you've created a CDC job for syncing the data from MySQL into payment, you could, there's a typo. You could also use them in Flink for doing any sort of joins, either a stream joins or lookup joins or any sort of joins within Flink, and process them. And the intermediate results of those processing can also be synced into payment, allowing it to be queried with other querying engines. And so the typically once the data is processed with a querying engine like or a stream processor with Flink, you'd also want to visualize it. So that also it's also something that you can do once you've written it into data lakehouse, you can visualize it with Tableau or Power BI or any of those tools. Okay, this is once again making a call to S3, which which might take a little time because of my internet connection. So in the meanwhile, let's also take a look at the Presto querying. So I'm going to exec into the Presto container, and now let's take a look at the catalogs. There should be a catalog for payment. So I've added the payment connector here. So the payment catalog is shown up here. Let's use the payment catalog and the schema S3 demo. And now if we look at the tables here, so the schema name comes from the table name that we defined in the CDC job. This is once again making a call to S3, which is why it is slow. But typically the infrastructure would be right next to S3, so you would see much faster results. Now let's query data from Presto as well. Okay, we have the data from Flink SQL here. So we have the 3 records that are linked into payment. We are able to query it with Flink SQL. Now let's also wait for the response from Presto, and finally we'll demonstrate schema evaluation, and we've got the same data here with Presto as well. Now let's do a schema evaluation, just add another column. Right now schema evaluation is only supported for adding columns or changing the names of columns or names of the or the data types of the columns, existing columns. So if you delete a column, that's not really going to be reflected here at the moment, because the project is in its early stages. That is, it's an incubating project in the Apache Foundation. The Apache Payment is an incubating project in Apache Foundation. So it's still in its early stages, but has seen some adoption as well. So we added a column. We should be able to see the schema changes being reflected in payment, but the actual changes will be reflected when we query only when there's new data being inserted. So added some new data with the new column containing some data. So I've added a column category and I've added some data for that particular category. Now, if we take a look at S3, we should be able to see another schema file that is generated, which contains the updated schema. So let's quickly verify that as well. There's another few bunch of schema files that are generated. Let's take a look at this. Final schema file. Let's open this. There's some intermediate schema files that are created as and when the records are being produced, as snapshots are being created. But the final schema file is where we'll find the updated schema. Here we can see the other column, the fourth column is also being added here, which means any data that we query now will also include the fourth column. Let's do a quick query in Presto. Seems like the new data was not synced, but the schema was synced. Let's check the Flink job. The records received is 6, which means it's read all 6 records. Maybe there's some delay in Presto querying it. Let's also do a query with Flink. It's usually real time. That is, there's not a lot of latency between the data source and what is synced because it's reading the bin log from the data source. So it's probably already synced to S3. It's maybe the query engine that is not picking it up. Let's check the S3 file system. There's a lot of network latency between my machine and AWS S3. That's the reason these queries are very slow. Yeah, now we are able to see the data. There's some network delay, but whatever changes that we make to the source database is now synced into the data lake host, which means this can be used for further processing. We can either do some processing with engines like Presto or even with Flink. So the idea was to demonstrate just the two of them, but there's a lot of other querying engines that are supported out of the box, which means the data, whatever source data is there, it is being synced real time into our data lake host, allowing for fast queries and real time queries. So with that, I think I'd like to wrap up. Yeah. So with that, I'll be recommend. Yeah. Great. No, at the moment, the CDC that payment supports, the MySQL CDC only supports adding columns or altering existing columns by either changing the name or the data type. But there's no support for when you delete a column or, basically when you delete a column, there's no support for that yet. That's because the project is in its early stages, but eventually that is on the roadmap. So any questions? Yeah. Right. Yes, but Druid is more for real-time analytics. That is, you want to quickly query data as and when it is coming. Although you can do that with a data lake host pattern as well, but Druid is more for real-time queries that are user-facing. So I think T showcased a few examples where any analytics that you look at in any apps, that is all powered by mostly real-time OLAP engines like Druid. Uh, but these data lake houses are more for the internal querying. That is, it's more for processing the data, that is joining, maybe doing a stream join or a lookup join, and then querying those results rather than doing user-facing analytics. Druid is more for user-facing real-time analytics. Yeah. Sorry, can we get you a mic?
Do you have a benchmarking chart for iceberg versus hoodie versus payment?
No, not at the moment, because Payment is in its very early stage. It's still an incubating project, so there's no such benchmarks that are being performed. But for the other two, I believe there are benchmarks that are there. But yeah, not at the moment for Payment.
Any large-scale company who has already adopted payment?
There's Verberica, who's offering a managed Flink service. So they are using Payment for their underlying storage. So it's that's the only one that I can think of. But there's also Alibaba, that is who's the engineers, a couple of engineers from Alibaba were the ones who created the project. So I believe they are also using it, but I'm not 100% sure. But yeah, these are the ones that I can think of. Yes, it's to you can query and then make data presentable so that Tableau or any other visualization tool can pick up that data and visualize it. So it's intermediate data before that, intermediate layer before that. Not sure. I haven't tried it out, but sorry, I don't have an answer for that.
My question is like, what problem exactly this payment is solving? Because for real-time analytics, we have like Druid, and for like batch analytics, even we can read the data from S3 itself. So like, where exactly this is lying and what use case it is being solved?
Yeah, so Payman is also going to support in the batch processing. That is, you store the data into S3 in a Payman format. So Payman is not an additional component by itself. It's more of a table format like Iceberg or Hoodie. It's just a way how the files are structured so that the querying is more native for Flink, and also the writing is more native for Flink. And it has the LSM data structure so that the reads are much more performant, and it basically what it allows. Right. No, the data is stored in Parquet, but the LSM structure is when it is being read. That is when the data is being read from the multiple Parquet files. The LSM data structure ensures that the compaction happens on read and not during write. So you can also there's a configuration that you can set so that all the Parquet files that are generated, or even ORC files for that matter, are compacted at a particular interval. So that's also something that you can do, but the LSM trees, the structure comes into place when you're querying the data. That is, the compaction happens on read. Updates for yeah, the default structure for the default table is the partition primary key table, where all data is that is if you have the same primary key record, that is updated, but I'm not sure about the underlying details of how it is implemented, but that is something that I'll need to check and get back. Right. If there are no other questions, I think we can wrap